I'm glad that you're watching me, and we are again once going to move to our topic on moles. Moles is one of the biggest topic in chemistry, and it also involves a lot of calculations. So you must be a lover of mathematics, and you must learn to practice working on mathematics concepts. 50% calculation, 50% explanations, which work together. So the name mole, it looks very small, but my English teacher way back in high school told me it's a noun, the mole. So that's what we are discussing today. And I ask you to be very attentive, get the simple concepts. As we move on from the beginning, you will realize that we are starting from the simple concepts as we graduate. We say that we move from known to unknown. Follow my steps on this mode. So we are going to start by dividing the word mole. When you are in Form 1, you are told that there is a topic in Form 3 called mole, which is very tough. And the good thing is, you need to tell that person that the topic was tough for you. It was tough for weak people. But for a strong person like you, it's not tough. Now, the mole. How can we define this mole? Any substance that has Avogadro's number of particles is a mole. Let me write here. Any substance that has or that contains Avogadro's number of particles, atoms, ions, molecules, etc. So any substance that contains Avogadro's number of particles, atoms, ions, molecules is called a mole. That's what is going to guide us through the entire topic. But you will realize we shall mostly be dealing with atoms and molecules. We shall, or you are required to know how to calculate the atoms and the molecules. So this is the definition of the word mole. Let's now proceed on. This is Avogadro's number. It's a constant that everyone should be knowing. A constant that everyone should be knowing. The way you have mastered your division number is the same way you are supposed to master Avogadro's number of particles. So always 6.023 times 10 power 23. That's the Avogadro's number. See, 6.023 times 10 power 23. Which can be particles, atoms, ions, or even molecules. The course book that we are going to use in this topic of mole, we are going to have a series of lessons. Because it's a very big one, we may have around 6 or 7 lessons, which I advise you to follow them keenly, step by step. Now, I thought someone has skipped my duster, but it's still there. Even if duster gets lost, I will write on top of what I have already written. Now, look for, let's start with the atom, like sodium. Sodium has the atomic number to be 11. This is the atomic number. What is the mass number of sodium? In most cases, you multiply by 2 the atomic number or you multiply by 2 and add 1. So in this case, for sodium, we are multiplying by 2, then we add 1. So the mass number is 23. So 1 mole of sodium has a mass number of 23. So it's very possible for us to calculate the number of atoms of sodium. And please follow every step. We cannot calculate the number of molecules of sodium. Reason being, sodium does not exist as a molecule. It exists as an atom. So in this case, 1 mole of sodium contains 6.023 times 10 power 23 atoms. So 1 mole of sodium, this 1 mole is 23 grams. It's a molar mass. I will not write the units because it's a ratio. We contain 6.023 times 10 power 23 atoms. Now, so if they ask you to calculate the number of atoms contained in, then you are given a given mass of sodium, then this is what you are supposed to use. If 23 grams is equivalent to 6.023 times 10 power 23 atoms, what about the 5 grams you have been asked? What about the 10 grams you have been asked? All true. Or someone can give you, calculate the number of atoms containing 0.2 moles of sodium. 1 mole contains this number of atoms. What about now the ones you have been asked? So dealing with the element that only exists as atom is not an issue. Let's get to oxygen. For example, calculate the number of atoms, that is A. B, molecules contained in 8 grams of oxygen. Calculate the number of atoms, that's for A. B, molecules contained in 8 grams of oxygen. So you see now, it is very possible to ask for the number of atoms and molecules of oxygen because oxygen, number one, it can exist in atomic state, at the same time it is in a molecular state. So when, we know very well that an oxygen atom has 16 molar mass. Oxygen molecule has 32. But now we have 8 grams. So when do we use 16 and when do we use 32? So because now we have known that 16 is for atom, that's when we are calculating the number of atoms. 32 is for the molecule. That is when it will be used when calculating for the number of molecules. So if I want to calculate the number of atoms here, 1 atom of oxygen has 16 grams. That 16 grams is the one that is containing 6.023 times 10 power 23 atoms. What about now the 8 grams? So this one, even you can now write here 16 grams. Though on that side it's a ratio, but of mass. So it's 16 grams containing 6.023 times 10 power 23 atoms. What about the 8 grams? You will get, the answer you will get 8 times 6.023 times 10 power 23 over 16. The answer you will get there will be in terms of atoms. If you want to get your molecules here, you will do this. 32 grams are contained in 6.023 times 10 power 23 molecules. What about the 8 class? 8 times 6.023 times 10 power 23 molecules divided by 32. Whatever you will get will be the molecules. So be aware when to use the atomic mass and the molecular mass. Those are just for the examples. So I say that we are going to follow, if there is a book that has been accredited for having good questions on moles, is the KLB. Try it. Answer all the questions there. You will not remain the same. Now, there are some things I want to explain again as we are moving on. You've heard me talking of molar mass, you've heard me talking of molecular mass, and I will still talk about it until the end of the topic. Molar mass, when I'm talking about the molar mass, it's only for a single atom, like the molar mass for potassium, like the molar mass for oxygen for a single atom. But if I talk of a molecular mass, of now 2 atoms forming a molecule, 32 is the molecular mass for oxygen, 16 is the molar mass for oxygen. But when we go ahead and we talk about now a substance that is a solid, for example sodium carbonate, whatever you will get, if you get the molar mass, in most cases we don't work with the molar mass, we work with the formula mass. And because it is a compound, we talk about relative formula mass. Then when we talk of a gas or a molecule like ammonia, it's a molecule, yes. So it's a molecular mass, but because it's a compound, we talk of a relative molecular mass. But all in all, you know what you have been talking about. You've just been calling it molar mass. No offense anyway. So that is it. So there are things here we need to know, and we need to clarify on them. Like calculation of moles, calculation of... Now, we have seen how to calculate molecules and atoms. Practice with more. So now, we need to move ahead. The topic is mole. So we need to know how can we calculate these moles. How do we calculate the moles? The basic one is when you have the molecular mass, or the molar mass, or whatever you have, the relative formula mass, and you have now the mass of the element or compound, you are able to get the number of moles. Now, a relationship or an equation connecting the three, number of moles, the molar mass, and the mass is this one. Moles is given by mass over, let me just write it, molar mass. Imagine just having a very simple formula like this. Then again in form theory, you know how to make one the subject of the formula. I can decide to make mass the subject of this formula. Mass is given out there, molar mass times the number of moles. You see? And if you want the molar mass, if you want to calculate the molar mass, how do you get it? So this is the first one, the second one. You want how to get the molar mass. It's given by mass over moles. So there is anything hard. There is nothing to make you scared of this. I don't know why. Most of you, they fear calculation of mathematics. It's not something to fear. Yani ikiwa hesabu ndogo unashindwa, lakini hesabu za pesa hautaibiwa pesa. You know very well. Ulikuwa na 5 ukaongeza 10 ukachukua mbao nikapeana nikanunua mtura ya 25 nikarudi mtu mwingine ambao you see by the end of the day you are very sure 10 imepotea ama pesa yako yote iko sawa, lakini ukiambiwa moles is given by molar mass unaanza kuona ni kama ni shida. Do you see the devil is showing with your life? Wake up. So now this is it. So let me say something about the molar mass. This molar mass can be replaced by the following: relative formula mass, molecular mass, relative molecular mass. All of them here. As long as molar mass is for a single atom, but no problem with that. So in some cases, the examiner can give you the molar mass, or in some cases, unaachiliwa ujipange mwenyewe. Uliamua au pangi. So the elements we always use are the ones that are common. Si lazima upewe na ukipewa na usipopewa pia usisema ati teacher there is something missing. Only those who are not ready keep on disturbing the teacher. There is a constant we are not given, like the cut was constant. Kuna wale, okay, it's a requirement that you are given, but even if we don't give you, please don't disturb us. Another way is when we shall be calculating the molecular mass for the sake of the compounds, or the relative formula mass for the sake of the compounds. But the others you are given. We are going to look at 3-4 examples on the KLP. I will tell you the page so that you can also follow and do more examples. But all of them requires you to work with this. Hakuna kitu kingine itakuwa nje hii. So, wacha nikuulize because uliambiwa kwa form 1 na tomorrow ni ngumu. Up to back mahali tumefika, umesikia kuna mahali ngumu. Na ni hivyo ndio tutaendelea mpaka at the end of the topic. So, we can open your those who have KLP. We can check on. I told you that's what we shall be using for our questions. So there is a question that is asked: how many atoms are there in 1 mole of oxygen atoms? Are there in 1 mole of oxygen atoms? So now you have been given the number of moles, 1 mole of oxygen atoms. Now umeulizwa how many atoms? So 1 mole of oxygen atoms contains 6.023 times 10 power 23 atoms. In fact, hapa kuna calculation na utaona mtu amechukua calculator ameji. What mass, another question, of oxygen atoms would you expect to contain the same number of atoms as 6 grams of carbon? A very nice question. What mass of oxygen atoms would you expect to contain the same number of atoms as 6 grams of carbon? I just give the way forward on how you can work with it. You have been given 6 grams of carbon. First of all, go ahead, calculate the number of atoms of 6 grams. Now, atom, carbon as one of the atoms is atomic number 6, meaning the molar mass is 12. But now, because they're asking of it only exists as atom. So 6 grams are contained, or 6 grams of carbon contains 6.023 times 10 power 23 atoms. That is it. Now, the same number now, you take it, then they ask you about oxygen. So it will just be 16 grams of oxygen, because 16 grams is the atomic mass of oxygen for 1 atom, not for the molecule. Another question: how many atoms are there in 20 grams of calcium? How many atoms are there in 20 grams of calcium? Sasa tuanzie hapa. The molar mass to calcium is 40. So 40 contains 6.023 times 10 power 23 atoms. What about the 20? You get your answer. Unless uniambia ujui tukisema what about ni nini tunafaa ufanye. Sawa? That is it. There's another very nice question here asking, name other elements which exist as a molecules. Name other elements that exist as a molecule. In short, apart from oxygen, what are the other elements that exist as molecule? One. So you know, some of you, let me now tell you who you are. They ask you, apart from oxygen, name other elements. Where we will answer now oxygen. So then okay, we have chlorine, we have hydrogen, we have nitrogen, we have fluorine, we have ozone. Ozone is oxygen, but 3 atoms. O3. This is ozone. O3. And many others that exist as molecules. So let me look for a very serious question that suits you. Now, get here. How many moles are there in 3 grams of carbon? How many moles are there in 3 grams of carbon? Let me write the board. I will employ someone to be cleaning the board for you. You can send your CV. So, how many moles are there in 3 grams of carbon? Moles in 3 grams of carbon. Sasa surely from the ile formulas tumeandika na tukafuta wanaulizia moles. Tukasema moles are given by mass over the molar mass. So hiyo moles is given by mass is 3 grams over the molar mass of carbon. What is C? C is always 12 over 12 here. You get? Let me work it out. 3 divided by 12. I'm just doing for your sake, otherwise for me I know. 0.25 moles. Na mtu anasema ati swali ni ngumu. Si ngumu, ndio wewe ndio unataka kupita. So another question. You have a book and a pen to write somewhere. I hope you are not watching me from a bed. How many moles are there in 4.6 grams of sodium? Moles in 4.6 grams of sodium. They're just asking about the number of moles in 4.6 grams of sodium. Moles is given by mass over the molar mass. Unless uniambie haujui molar mass ya sodium ni 23. So it's going to be given by mass 4.6 over 23. It will give you something like 0.2. But that's what it will be. So that is divided by 23. 0.3. 0.2 moles. You can now work with others. So that one required you to calculate the moles. Let's see the one that requires us to calculate something else. Calculate the mass of 0.2 moles of beryllium. Calculate the mass of 0.2 moles of beryllium. Beryllium. That is beryllium. It exists as it's 9. The molar mass is 9. So now, and we have been asked what is the mass, and the moles are. Nimesema moles ngapi? Nimesema moles ni 0.25. You have the molar mass, you have the moles. Mass nilisema, it is given by the molecular mass times the number of moles. So the mass is going to be which will give you what you will get there. 0.25 times 9 grams. It's only when you will be calculating the molecular mass that you will not put the units. And the reason is very simple. It is a ratio. So you will not put the units there when it's a mass, molecular mass, that is. Now, the question is here. Calculate the molar mass of an element if a mass of 5.6 grams contains 0.1 moles of the element. You have the moles, 0.1 moles, and you have the mass, which is 5.6. They're asking me about the molar mass. To confirm, a molar mass is given by mass over the number of moles. So 5.6 over 0.1, you will get 56. 56, not 56 moles, just 56. Now, you know what we have done? We've just calculated the moles, molar mass, molecular mass, but using simple elements. I want us to graduate now, and we use compounds. First, we need to learn to calculate the relative formula mass of compounds. When you are given sodium sulfate, what is the relative formula mass, RFM? When you are given sodium carbonate, when you are given nitric acid, sulfuric acid, any other compound, and in fact, for your information, you will just be rotating with the same compounds. In fact, sodium carbonate is one of the most used. Sodium sulfate, these things are very common to you. So when you master it once, it will just be repeating itself. And now ukikutana at 19 and new pair, it's a way of knowing what the better. Look at this question. This is carbon dioxide. What is the RFM of this? What is the relative molecular mass of this RMM? It's a molecule. So first of all, we need to see what are the atoms making up the compound. It is carbon and oxygen, but oxygens are 2. So we need to go aside to choose the carbon is 12, oxygen is 16. But this carbon is 12, oxygen is 16, but it is 2, in a quarter 2. So the whole of it will give you 44. That is it for a compound. 20 sodium carbonate. Sodium carbonate, the RFM sodium carbonate. Very simple. What are the atoms making up sodium carbonate? Sodium, carbon, and oxygen. Sodium are 2, carbon is 1, oxygens are 3. So the examiner may be called and gives you the atomic mass. So sodium 23, carbon 12, oxygen 16. There is someone who is tempted to add here. May God forbid. So sodium here 2, so it's going to be 46. Carbon is simply 1, it's going to be 12. Then plus 16 times 3 is 48. This one will give you 1 and 6. That's what we do. First of all, know how to write a chemical formula for sodium carbonate. Because just imagine you've gone wrong now, umekosea. Patala uandike Na2 carbonate, you write Na carbonate, then you skip these 2. You will get wrong calculation. So that is the importance of now writing the correct formula, and that's why we insisted in forms that you should know how to write such formulas very well. In this level, please, you will not work with moles very well. Hautaelewana na moles vizuri kama hutaki kujua how to write chemical formulas. Kuna mwingine ndamwambia sasa yeye aandike sulfur, sodium sulfate, ataandika vitu zake. So let's look at the one for sodium sulfate. Sodium sulfate. You pause the video, then write sodium sulfate. When you are done, you proceed. Uone kama umeandika the correct thing. Sasa angalia vitu mbona naandika. Anyway, it's well. So sodium is 23 and it is 2. So it's going to give us 46. Plus sulfur, atomic number 16, mass number 32. Oxygen 16, but we have 4 atoms, 64. You add this, you get the molar. You get the relative molar mass of this. Relative molecular mass RFM zote. As long as umefanya vile nimesema. So another question as we are ending our lesson. What percentage of by mass of sodium is there in 1 mole of sodium nitrate? What percentage of mass of sodium is there in 1 mole of sodium nitrate? Now this one. What is the percentage of sodium atom in sodium nitrate? So kwanza andika sodium nitrate. That way. Then we can, what is the percentage of sodium? So kwanza we look for the whole RFM, then for sodium alone. For the whole of it is going to be 46 plus nitrogen is 14 plus 48. Don't ask me why 48. It is 3 atoms of oxygen. I'm saying so because I can imagine some of you, if you were seated somewhere, you would be raising your hands to ask why 48. I'm saying it's 48 because oxygens are 3 and 1 is 16. So it's 48. So you get, to save time, ningekuwa nimefanya lakini wacha nitumie calculator. 108. You can do from your side. Then for sodium is 23. Hey. Make that correction. 23 plus 14 plus 48 give us 85. Then now for sodium alone it is 23. So it's going to be 23 over 85 times 100%. That will give the percentage of sodium in sodium nitrate. So 23 divided by 85 times 100, 27%. Thank you. So just move to the next video for moles. We proceed. Have a nice time, and I don't take for granted that you are watching this channel. God bless you.